We might be completely alone. Not just in our galaxy, but in the entire observable universe. In a cosmos with billions of galaxies, each containing billions of stars, many surrounded by planets that could support life, the silence just doesn't make sense. Because if life could emerge here, on an ordinary planet orbiting an ordinary star, then statistically it should have happened many times before. Yet after decades of searching, there are no signals, no probes, nothing. This mismatch between what the universe should look like and what we actually see has a name: the Fermi Paradox. It doesn't give us an answer. It highlights a gap between what the universe should look like and what we actually see. And that gap raises a simple question. If intelligent life should be common, where is everyone? The paradox comes from a collision of ideas. On one hand, the universe is about 13.8 billion years old. Our galaxy alone contains hundreds of billions of stars. Many of them host planets in regions where liquid water could exist. On Earth, life appeared relatively quickly once conditions allowed it. If you run those facts forward, it's hard to escape the conclusion. Statistically, we shouldn't be first. They should have left signs. They didn't. We see no evidence of anyone else. No vast structures harvesting starlight. No self-replicating probes spreading through the galaxy. No artificial signals drifting between the stars. The universe looks empty, unused. And that emptiness is the heart of the paradox. One possible answer is the simplest. Maybe we just haven't looked enough yet. SETI programs have scanned only a tiny fraction of stars in our galaxy across limited frequencies for limited periods of time. Imagine standing in a vast forest at night, sweeping a flashlight between the trees for 30 seconds and concluding the forest is empty. That's roughly where we are. The silence might not mean no one is there. It might mean the universe is full of life, and we don't know how to hear it. Some explanations make the universe feel lonely, and others make it feel dangerous. There's an assumption we rarely challenge, that advanced civilizations somewhere in the universe would be loud. But would they? Our own technology is already moving in the opposite direction. We've shifted from broadcast radio to fiber optics, from scattering signals in every direction to sending information precisely where it's needed. Our technology isn't getting louder. It's getting quieter, more efficient, harder to notice from far away. If another civilization followed a similar technological path, they might be invisible to us, not because they're hiding, but because progress often means producing less noise, not more. Or they may have moved from anything we'd recognize as communication. Technologies that don't radiate into space, don't announce themselves, don't leave traces we know how to read. In that case, we wouldn't just be missing the signal. We'd be searching for something that was never meant to be found. But there's a darker possibility, one that reframes the question entirely. The Great Filter. The idea is that somewhere between lifeless chemistry and a spacefaring civilization, there's a step, or several, that almost no one survives. A barrier so severe that most paths end there. And if that's true, it would explain why the galaxy still looks empty. Maybe complex cells almost never evolve. Maybe the origin of life is extraordinarily rare. And perhaps intelligence itself is a cosmic accident. If that is true, then we're unfathomably lucky to have beaten the odds so far. Maybe civilizations tend to destroy themselves shortly after developing powerful technologies like nuclear weapons, artificial intelligence, or bioengineering. Maybe the gap between being technologically capable and being wise enough to survive is one most species never cross. If that's the case, then the silence isn't a mystery. It's a warning. But there's a worse explanation. What if they're out there, but staying quiet on purpose? The zoo hypothesis suggests advanced civilizations might observe younger ones without interfering, the way humans watch animals who don't know they're being watched. That kind of silence comes from restraint, but not all silence does. Sometimes silence is learned. If the universe is dangerous, broadcasting your location could be fatal. The Fermi Paradox wouldn't be a paradox at all. It would be exactly what we should expect. And our own radio signals leaking into space for barely a century might be the most reckless thing we've ever done. But there are stranger possibilities. Perhaps advanced civilizations don't colonize space at all. Maybe they turn inward into virtual worlds more compelling than physical reality. Or they slow themselves down, entering long periods of hibernation, waiting for a universe where energy goes further. Maybe large-scale engineering does exist, but it's subtle, quiet, unrecognizable to us. There are many ways to explain the silence. None of them are completely comforting. But one recent idea suggests the answer might not be in the stars, but beneath our feet. Life may be common, but the kind of life that builds technology might require a very specific kind of planet. Early life likely needs oceans, but advanced technology needs dry land, and a planet needs to keep changing for billions of years, reshaping environments, pushing life to adapt. Earth took a very long time to reach this balance. Complex life followed soon after. If this is correct, then planets capable of producing technological civilizations may be far rarer than we imagined. Not because life is impossible elsewhere, but because the path from microbes to machines may be much harder to complete. Or maybe, and this matters, our entire framework is wrong. Every major discovery in astronomy has come from realizing the universe is stranger than we thought. Perhaps intelligence is stranger, too. The silence doesn't give us a single answer. It gives us possibilities, and every one of them matters. Life might be rare, it might be quiet, it might be fragile, or we might simply be early, among the first to look up and ask the question. Here's what we do know. Right now, on planet Earth, we are the only technological intelligence we can confirm. The only minds we know of capable of asking why the stars are silent. And if we really are rare, then what we do next isn't just important to us. It might be important to the universe itself.